All right, so people often panic when it comes time to multiply matrices. That's like kind of the big pain. Um, but when they are panicking and it's really confusing and overwhelming, um, they're not talking about scalar multiplication. So we're going to talk about scalar multiplication, which is actually easy. So don't be frightened by the word multiplication next to the word matrix in this lesson. This is very straightforward. Um, Multiplying one matrix by another matrix, that's tough. Um, Multiplying a matrix by a scalar is not tough. So let's just review some terms though first. The matrix is a system, Neo, specifically a system of organizing data into rows and columns. That's all it is. Like Excel, a spreadsheet. That's a matrix. Rows and columns. Um, the elements of the matrices are the individual numbers that populate the matrices. So 6 is an element of matrix A. The dimensions of a matrix are the rows by column. So um, this matrix A, has 1, 2 rows and 1, 2, 3, 4, 5 columns. So it's a 2 by 5 matrix. Okay, now a scalar is a number which you can multiply with a matrix to scale it up or down. So I mean, let's think back on the concept of scale just in general. If I have a if I have um, a little box here, excuse me, a box. It's like 3 by 3 by 3, and I wanted to scale it up um, and make it a that's gonna be 12 by 12 by 12. I'm I'm kind of expanding. I'm blowing it up. What do I multiply every dimension by? I multiply by 4. So I'm multiplying this side by 4 to get 12. 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 So this box is 4 times as large as this box. Or in other words, this box is a scaled down version of this box. Okay. So multiplying a matrix by a scalar is scaling it up by a certain number. In other words, taking every element and multiplying it by the scalar. That's all. So let me actually delete all this stuff to make some room here. So I've got matrix, it's a random matrix. It doesn't mean anything. I just picked out some random numbers. This is matrix A. Usually when you name matrices, you give it a capital letter. Um, and what I'm going to do is I'm going to multiply it by a scalar. I'm going to scale it up. And the way I've showed what I'm about to do is I said 2a. Um, just like in algebra, you know, y equals 2x. That 2x means 2 times x. Okay, so I'm multiplying this matrix A by 2. So this 2 is my scalar here. Negative 3 is gonna be my scalar there. So I take every element and I multiply it by the scalar. That's it. So let me first draw my new matrix. Um, so I'm gonna have 2 rows and 5 columns. So I take each element and put it in where it belongs in the new matrix. Except I'm just multiplying it by 2. So 1 times 2 is 2. 6 times 2 is 12. 4 times 2 is 8. 2 times 2 is 4. 1 times 2 is 2. 2 times 2 is 4. 5 times 2 is 10. 2 times 2 is 4. 8 times 2 is 16. 8 times 2 is 16. Okay, that's it. So this matrix is a scaled up version of this matrix. Every element is multiplied by a factor of 2. And then you can write it a little bit neater than I did. Just make sure that the columns line up, the rows are neat, so it's easy to tell where elements belong. All right, so I'm gonna do another one real quick, and then I'll let you do these scalar multiplications. So Now I want to do I want to multiply matrix A by -3. So 1 times -3 is -3. 6 times -3 is -18. 4 times -3 is -12. 2 times -3 is -6. 1 times -3 is -3. 2 times -3 is -6. 5 times -3, -15. 2 times -3 is -6. 8 times -3 is 24. -24. And another -24. Alright, it's a little sloppy. Do it better than I just did it. Yeah, so that's it. So here's matrix B. The dimensions are different here. Multiply by scalar 4 and then -1 also, just to practice that. And this will be an important skill, because when you start getting into elementary row operations, you'll be doing something that is a little bit difficult to keep track of, which is you can take a row and add to it the values of another row multiplied by a scalar. So get this under your belt first, and then you can move on to some cool stuff. So enjoy.